As you guys know, it's been a very long time since we've had a long break for the videos. But yes, we are back again. So we have a 15 inches in front of us, and it's a low power. So a brief introduction about this machine. This is an A1990, and the approach here, it's not just for A1990, but it's a general approach. Now, when you have a machine that comes in for a low power, and you do not have idea about the state of the board. So yes, it's one thing for the client to say that the machine doesn't power on, but then you need to understand what is the state of the board. The reason why that is important is knowing the state of the board will allow you to determine if it's safe to connect power to the device. Say for example, if there is something wrong on the PP bus line. Now, PP bus line, just gonna show you. Okay, so let's open up the board view. The board view, it's gonna be 820-0, what is that again? Okay, yeah, 01041. So that's the board view for the board that we have in front of us, which is 15 inches A1990. Then every logic board of Apple, they will have a universal primary code, which will start with 820. So the 820, it's general across all of the boards. So all of the boards will have 820. The most important numbers will be the 4 after the 820. So 820-01041. So that is the board. That's the board number for 15 inches A1990. By the way, the A1990s, you have it in 2018 as well as 2019. So the A1990 was discontinued in 2019, basically. So you have the 2018 version and the 2019 version. So the next time there was the next lineup after the A1990 was the A2141, which is the 16 inches. So the board numbers, the A1990 will be the model number, and then the 820-01041, is that 41? 010, yes, is it? So 820-01041, that will be the board number. Okay, so I was talking about, so one of the reasons why it is not okay, on your board you have a couple of buck converters. A very popular one is going to be your U9080. Now, your U9080, it's a buck converter that basically takes a high voltage and turns it into a low voltage. Now, the way that works, it's in a very common sense, it's that the chip itself is going to switch on and off until it evens out. So let us go to the schematic of that so that we get a better understanding of what I'm trying to say. So it's 820 dash. Let's search 820-01041. Okay, so let's go to U9080. Is that U9081? U9081. Show this. Sorry, U9080, not 81. Okay, U9080. Now on my schematic, in order for me to identify that chip, the chip I'm talking about, I go to my schematic, I make sure the board number is the same thing, which is 820-0141, and then I can type in the board the chip ID. Chip ID in this case is basically, the chip ID might not necessarily be what you will need when you're purchasing a chip. So the actual chip ID would be this. See where it says TPS 62180, that would be the actual chip ID. But for the schematic itself, this is how we identify it, which is U9080. Now, U9080 is a buck converter. So it turns out, so you see on your left, I'm just going to do this. Now on the left side of the chip, it's going to have a PP bus voltage that will come in. So you see where it says V in. So that is on the left side of the chip. Now it's going to take a high voltage and then turns it into a low voltage. Now here it says PP bus. PP bus is going to be about 12.6 on this board, and then the output of that same chip is going to be, you see, it has more than one output. So you have 1 and 2. The first output is going to be 2.5 volt, and then you have another output which is also 2.5 volt. Now this chip is going to switch on and off until it's able to even out. There's a more detailed explanation of how that actually works. But the gist of it is it takes a high voltage and then it turns it into a low voltage. Now, when this chip fails, what will happen is, say for example, you don't know the state of the board, and then you connect power to the device, and it just turns out that this chip A1990, which is very common to fail, by the way, it turns out that the chip has failed. What will happen is, instead of the chip evening out, basically converting 12 volt into 2.5 volt, the voltage that it receives here, it will send it exactly out. Now, when that happens is the output of that chip goes to the NAND, which is the SSD. Now, when that happens is when the chips, which are the SSDs that are supposed to receive 2.5 volt, receive 12.6 volt, which are coming from the previous slide, what happens is you will kill the SSD. So the general way you go about addressing issues, a board that has been undefined, which is a board that you've not defined to know what state the board is to, first of all, get an idea of what is happening to the board before you connect power to it. So this one is a no power. We are not going to connect a charger to it. The first thing we want to do is we want to take out the back plate, the back cover, and then we define the state of the board, and then I'll walk you guys through how you can define that. So the first thing we want to do is to open up the machine, and obviously we know. But then another thing is, we can try to switch it on. There's no problem in trying to switch it on. But what we are not going to do is we are not going to connect power to it. So it's now the next thing we want to do is to take out the back cover. We are going to need a P5 for that. So I try to start with I try to go in an orderly manner, and also I try to also protect the screw, by placing my hand beside it so that I do not scratch the back of the device. Okay, my screws are out. Now there are a couple of ways you can take out the back plate. So you can choose to. Myself, I usually would use the side here, but it works easy if you have a suction cup to basically clip and lift before you open it up. Well, for me, because there's an opening here, so what I usually would do is I use my fingers to go through the opening just to get a bit of a lift, and then I can lift it up, which is what I'm going to do now. So I'm just going to get a bit of a lift there. And then clip, and then on the right side, I start from the right side first, and then the left, and that's how I take it out. So what I would usually do is I make sure all of my screws are put in one place. Now, if this was going to be my first time to do this, so what I would generally do is I will be very aware, because to start with, the screws that I take out, they are not of the same length. So the two on the hinge, which is the ones that we took out from here, they are of the same size, and then the ones that we took out from here, they are of the same size. So you have two long, and then the four will be considered as short. So that is that. And then when you have a machine like this, when you're diagnosing your machine, the first thing you want to do after the back cover is out is to disconnect the battery. Now the battery configuration settings we have here, we have two settings. We have the battery cable and the main battery power line. So the battery cable, it's this guy here. This is the battery cable. When I disconnect the battery cable, power will no longer flow from the battery to the board. That is the ideal situation. However, sometimes if the battery itself, it's not an Apple battery, if it's a Chinese battery, you may find yourself in a situation whereby even though the cable itself is disconnected, the battery is still supplying power to the board. That is an abnormal battery, but that is also something you can find if you get a Chinese battery. So the safest option would be to also remove the battery power, which you need a screw, and a T5 is going to do that work for you. So we use a T5 to disconnect the battery. To disconnect the battery screw. Okay, then that's out. Now, in terms of battery screw identification, that is the screw. That's the only screw that looks like that in the entire board. I mean, no other screw looks like that, so it will be easy for you to identify where that goes. Now, if this is my first time, I have to be very careful in trying to identify the position of the screws as well as the length of the screws. So yeah, now from this here looks like the board, it's a liquid damage board, so but we're not sure, but this definitely looks like a liquid. And then we have this section here, we have also something that looks like liquid in that section there. So what you want to do now is we want to make sure that we do not have a short on the board. Now, short on the board, it's we are going to start by checking our PP bus rail. So for PP bus rail, we can easily use the two fuses. For our PP bus, we can use these two fuses here, F7000 and F7001. These two guys here, we can use them to check. So the reason why we're using these fuses is because the fuses are sitting on the PP bus power rail. So whatever we measure here, whatever we get here, it's practically that what we measure here will mean that we are tacked directly onto our PP bus rail, which is the PP bus line. So the first thing we want to do is we want to check if we have a short on our PP bus. Now, depending on the type of board you're working on, that will determine the first line of troubleshoot, or the first line of measurement to make. Because A1990s are very common, they commonly, because C9081 on the A1990, I have a couple of videos describing that. C9081 is a capacitor on that is C9081. So if we go to our schematic again, here we will see C9081. You see C9081 is one of the capacitors on your input rail, which is a PP bus rail to your U9080. Now this cap often fails because of the location, because of its location on the board. And then I've also I have a video explaining why that cap usually fail. I mean, you have it's a combination of a moisture as well as dust in that particular location. So you can watch more on that on the channel. But that capacitor often fails, so especially on the A1990s. So when that fails, what will happen is when you measure here, you will have a short on your PV bus, which would then mean that the device is not going to turn on. So we are not sure if the problem we're having here is because of the signs of liquid that we see here, which could suggest that the device itself is liquid damage, or it could be that the problem that we're having, that we have a short on our PV bus. Now, just before we continue, now the C9081 fails in two ways. C9081 fails in two ways. Again, I have explained that before, but I'm just going to go briefly on how it fails. Now, one way it fails would be that C9081 itself. So you have a short which will be created by C9081. Now, when it fails within itself, is when you remove C9081 from the circuitry, what happens is the short will be gone and your issue is resolved. That's scenario A. Scenario B is C9081 has failed, and then what happens is it basically burns a hole onto the board, which then affects U9080, and then there was still power enough to power U9080, that U9080 then sends 12.6 volts. So it destroys U9080, and then U9080, the scenario that we described, U9080 then sends 12.6 volt onto the rail that's supposed to receive a 2.5 volt. So which would then mean in a situation like that, even after you remove C9080, the short is not going to be, you will not be able to address the short. Now, to fix a problem like that, you have to remove C9080, you have to replace U9080 as well as C9081, U9080, as well as the NAND chips. And then in this case, about the NAND chips, you are not going to replace just the one that fails because of signature purposes. You have to replace the entire NAND chip. So that's just basically how C9081, how C9081, those are the two ways C9081 fails. Now back to our board. So we have a low power board, so we have the backplate out, we have our battery disconnected, and then now we want to see if we have a short on the board before we take the board out. So we want to switch our multimeter into continuity mode, and then if you don't know about multimeter settings, now you see my setting here. I have the diode mode as well as the continuity mode. I'm going to use the continuity mode. Now, one of the ways you can confirm, although this is, I have other multimeters that obviously, for example, if I use this one here, this guy here can show me, I can switch between, you see that sign, that tells me that I am now on continuity mode, and if I switch it, that tells me that I am now on diode mode. Now, but with this guy here, I prefer to use this guy because it's very loud. Though it's small, but it's very loud. This guy is not as loud as this guy, so I prefer to use this only for my continuity measurement. So it's set to continuity, and one of the ways you can confirm is the beep. You see that beep, that tells me that I have continuity across both probes. Then another thing I also want to mention, depending on the rail that you're working on, and then depending on do not only depend on the beep that you get. It's also important to get to see the figures that that you are getting on your display, because sometimes you may get a beep, but that's not a short. It's just because of you have because of the rail that you're working on. Okay, so now we're back. So what we want to do now is we want to check for continuity. So we want to see if we have a continuity, if the PP bus is making its way to ground. One of the ways we can do that is we did this, for example. Now it beeps and then we have 0 across, which tells us, I'm going to switch this off so that I don't confuse you guys. Now when I do this, it beeps and then it gives me 0 across. So it tells me that my probe A is equal to probe B, meaning that A and B are connected as one. Now this is my ground. I can use this as my ground, I can use that as my ground. What we want to do is we want to confirm if PP bus is connected, if this line here is connected to ground. Now, just the way we did this, by just the way we did this, and then it shows that we're connected to, it's connected as one. What we want to do is, ideally, this is my ground here, and this ground here, they are supposed to be, because it is ground. However, if I take my probe and place it here, if this line here is connected to ground, it will beep, which will tell me that I have a problem. But if it does not beep, it means that I do not have a problem with my PP bus. So let's do that. And then it beeps. Now it tells me that I have a problem. So I'm just going to bring a board, and then I'll show you guys what it's supposed to be. 1 minute. Donatus, I'll be with you, okay? I'll be with you. I'm not sure if this board here has an issue on PP bus, but I'm just going to check. So in an ideal situation, so by the way, when you're checking for your short, it doesn't really matter if you have your red probe on ground and then your black probe. That is on your continuity. But then if you are using your diode mode, it does matter when you're measuring in diode mode. So yeah, so let's see, we have our black on a screw hole, which is ground, and then another one on a screw hole, which is ground. So we have, definitely it tells us that we are measuring the same thing. So let's see on our PP bus line, what do we have? Now this is the ideal measurements. Okay, yeah, so this is what is supposed to be. So that tells us that we do not have. So what is basically saying is that this has no communication with that. That's what it means. So basically our PP, so this is what we are supposed to be expecting on this board here. So we are not supposed to get a beep. The fact that we're getting a beep, it means that we have a short. Now, what does that mean? So, if we go to our schematic here, now, schematic here, these are caps. Now, you have, here it says 1, and then here it says 2. So, there are two ends of this cap, a capacitor. One side, it says, this is ground. We have, and then the top of it is going to be the main line. In an ideal situation, when this and this are not supposed to be equal. This is the main line and then this is ground. However, when a capacitor fails, what would then happen is pin 1 and pin 2 will become equal, which would then mean that whatever you have on your pin 1, which is supposed to be main line, is going to be equal to pin 2. So that is the situation that we're having here. The next step now is for us to narrow down exactly where the short is coming from. you can easily guess that it's going to come from C9081, and then you can also easily guess that, and then the reason why you would guess that is because that's a common failure with the A1990s. Let's see, what did we do? So that is a common failure with the A1990. That's one of the commonest issues you will find with A1990. So the next thing we're going to do is to quickly take the board out. Now, in taking the board out, there are the screws that you need. There are 3 screw sets that I'm going to need. I'm going to need a T5, a T6, and a T4. So I usually like to start with the T5 screws. So I quickly I start with the T5 screws. And then after the T5, then I go T4, and then finally the 2 screws, which are going to be the T6, are going to be the ones that I take out last. Now, all of this, they are of the same sizes, all of this, yeah, except the one here. The one here is slightly longer than all of the rest, even though this is the same beats that you need to use, the same T5. So 1, 2, 3, 4, 5, 6, they are all of the same sizes, except this. This is going to be slightly longer. Now, that is not the factory screw. The screw has been changed. So somebody must have taken this out before. That's not the factory screw. The factory screw, the one that goes here, will be slightly longer. So let's just see if the screws here. Okay, no, the screw is not here. Now this is the factory screw. Is going to be slightly longer than the rest of it. Slightly longer, but not that long. So now the next thing we want to do is we want to use the T4. So after I use my T5, the next thing I want to do is I use my T4. Hassan, the MacBook Air for battery, correct? Yeah, it's there. No, it's fine. The one for battery is there. Is it still for Fahim? Okay, I'll give you now. So the one for Fahim, this is yours, and I want gadget is this one. No. Let me see.
What are you giving me?
No. Yeah. Generators are the 2 that are, you see, those that are working. Yeah, is that guy here. Is that one. And this guy. So, and I forgot about the charger.
Did he pay you?
No.
Are you gonna send a message?
Yeah.
Okay.
Don't worry. Yes. Okay.
Can be battery.
The battery. Yeah, I've got.
Battery.
Yeah,
I'll
I've got
do
it.
it.
Yeah, but it's easy to do also.
Yeah. I don't want to put battery. Battery. It's a new one, huh?
Yeah.
Must I put a sticker for 6 months, huh?
Please.
Okay, I'll do it for you. It's easy.
Yeah.
It's only 4 screws.
Yeah.
I'll EFT, huh? Please.
Okay, not a problem.
Jazakallah.
Wa alaikum salam. It's 450.
Oh, you didn't deduct from that?
No. Yeah, so can pay at your convenience. Okay, thank you. Okay, so yeah, so I use my T5 and then I follow up with my T4. Depending on the beats that you're using, you can also use a T3 for this. Actually, I prefer to use my own T3. Let me fetch that one. Okay, so yeah, I prefer to use this because it's more. I'm using a T3, and then now the screws. Now this guy here, they are almost the same size as the ones we took out here. But one of the ways you can differentiate them is the cap. The cap will be slightly bigger, but the length might be confusing. You might confuse them. So 1, 2, 3, 4, they look very similar, even though they're not. So that's also something to keep in mind. So these are the T6s, T8, sorry, not T6. So 6 is not gonna be enough. So we're using a T8 here. So we've taken those out. Then we want to do, now Apple referred to this as cowlings. So this is the ones that they refer to as cowling. So, and a screen. So you see, I try to go through it in an orderly manner. So that way also I'm able to identify the screw sizes. It's important to understand the screw sizes as well as the locations of the screws. Now the hinge cover. The hinge cover, the screws that goes onto the hinge cover, they're actually unique. They look completely different from the rest. So you should have 4 of those. So 2 will be on the right and then 2 will be on the left. Now the screws that goes onto the touch bar cable, and the screw that goes onto the USB-C port connector are of the same length. So you have 5 of this. You should have 5 of this. So 2 on the right and then 2 on the left. Okay, and then the next thing we want to do is we want to use our T8. You can also use a T7 depending on how big your T7 is. So that's it. So all of the screws are out. So you see, another thing I try to do is I try to basically go over it in sequence. So first I use my T5, and then I use my T4, and then I use my T8 or T7 depending on what you have. And then afterwards, now I want to disconnect my cables. Now okay, this counting I didn't check out. So the one cable that you disconnect first, it's going to be the first cable you disconnect from the machine is going to be the battery communication to the board, and the last cable to connect will be the battery communication to the board. So then after that, the next thing we want to do is we want to disconnect the cables. And then while you're doing that, it's the best is always to use your fingers to do the disconnection of the cables, because that means you are fully in control. Now when it comes to the antenna cables, you just do that. Very easy to disconnect, nothing major. Okay, so and then also while you're doing this, it's also very important that you're not distracted. It's important because I mean this is a client's machine, and it's something that's interested in your care. So you make sure you're not distracted so as not to make a mistake. You need all of the attention. You need to give it all of the attention, not to get carried away. Okay, so whenever you have any form of resistance, you want to be sure where that resistance is coming from. All of the cables here, when they break, with the exception of your screen, the screen cable, in this case you don't have actually screen cables that are pointing out. In some you do have. So sensitive cables will be cables that are coming from the screen, and then the touch ID. And because when the touch ID breaks, it means that you either have to run a wire for the touch ID, or because the touch ID is tied to the board. So you have to be very careful that the touch ID doesn't break. Now, another thing I like to also do is to mark the boards. For example, so just put any type of code here, so that you are fully aware what belongs to what, because you might probably have so many of this, so many A1990 that are open. So you want to know exactly what belongs to what. So it's good to put some kind of marking on the parts of the machine once the board is out. Now, up until this moment, as you guys see, that we did not connect power to the device, because it is not time to connect power to the device yet. Now, this is the board that we had used to confirm if it's working. Now, this is our board. So the first thing we want to do is we want to flip the board to the other side, to the location of C9081, to see how it looks. C9081 is going to be this guy here, which is on the other side of the board. So let's flip it. And this is C9081. You see the way it looks here. You see that section there. So this section will always look clean, but that section there looks a bit corroded. Now that doesn't really look corroded enough to be a problem right now, but sometimes it still does turn out as a problem. So just so let's confirm again what state we are still in on the board. So we want to use our multimeter, and then our black probe to ground, and then our red probe. We want to see what we have. Yes, we do have a short. Now, one of the reasons why I just measure to confirm. Sometimes you may have, because your trackpad also, there is also a PP bus voltage going to your trackpad, and that you can find from here. See where it says F67000. Now that it says PPV in underscore G3H, which is G3 hot underscore trackpad underscore fuse. Now, by the way, whenever I see G3H, it means that it's always present. That's what G3H means. Now, this fuse enables a communication between your board and your trackpad. In terms of PP bus makes its way to the trackpad from here. So sometimes you may have a problem from your trackpad. So when the trackpad is connected, obviously you have a short because of the fuse here. But when the trackpad is disconnected, the short should be gone. So again, you want to measure just to confirm that the short that we're having is not coming from the trackpad. Although with the A1990 that is not common. What is common is to have a short on the side of the C9081. So what we're going to do is we are not going to use hot air. We're just going to use a tweezer or anything just to remove, to basically to take out the capacitor. We just do that, and that's it. The cap is out. Now we want to check again to see what we have. Left, and our short is gone. You see that? Now our short is gone. Remember initially when we were measuring that, we were getting a beep. Now with that cap out of the way, our short is gone. Now this was the problem. This was the problem of this board all along. Now it's important now. And then another thing is, one of the ways you can also tell that there was no damage to it is, you see the way that looks. I'm going to get you another board that will look different. Okay, so you see this board here, this is also an A1990 board. So one of the ways you can tell that probably it's not going to be a good one, it's, you see that becomes blackened. Say again? You see that, so you see that becomes, the pad is gone. Now when you have that, that's not a good thing, because that is most likely, that would most likely be that not only, so the second scenario that I described, that, so this is a scenario whereby the capacitor in itself failed, yes, but didn't do further damage. But in this board, the capacitor did not just fail, but it did more damage, which would then mean that our C9080 most probably is also gone. So usually when you see that, then it's not so promising. Yes, you can dig a hole, and then which is so, but at the end of the day, most likely you will no longer be able to have data will not be carried over. So that's just the second scenario that I was describing. So with this one, that is all we need for the fix. And interestingly, you might ask yourself, well, is that all? Why don't you put back the cap? We are not even going to put back C9080. Why is that? Because if you look at now, you have 1, 2, 3, 4, correct? Now yes, it says it's critical, yes. However, we have 1, 2, 3 4 that basically are doing the same thing that this is going to do. So even though we no longer, even with this out of the way, the circuitry is going to perform 100% without any form of deficiency. Now, why do we not put it back? So what we have found is this. Now, the failure, it's something that happens over a period of time. So if we put the capacitor back, the same thing that happened to the first one is going to happen to the second one. And then sometimes the client might not be as lucky as the second time when it happens, which would then mean, because this time when it happened, the capacitor failed, but then it did not affect anything else like your A1990. But it may fail in a way that it just like the other board that we showed, that it didn't just fail in itself, it also affects A1980. So we are not going to put it back, and now we can put the board in the shell. We can't test the board while it's out, but we just want to put it in the shell and then test to see how it behaves. So hopefully, if that is the only issue, the board should be running now. And then and I also like to stress, make sure that when you are busy with your shell, that the shell is open and your keyboard is resting. Your keyboard trackpad is resting on your table and not allowing the screen to rest on the table. And again, it's important that when you're standing up, if you choose to do this when you're standing up, always be aware not to basically knock off your screen, and that will be disastrous. Okay, so now we want to put back the board to test. So if that's the only problem, then we should have a functioning board. Sometimes you may have multiple problems in one board. Now, another thing I want to stress is whenever you're using a tool for anything on the board, make sure you are fully in control. Do not hand over control to a tool, because when you hand over control to a tool, what happens is you may probably be ripping up something, but you wouldn't know that you're doing that. So we are going to connect minimal cables just to do the testing. We'll need the screen cable. We'll need the keyboard. We'll need not necessarily the keyboard, but definitely we'll need the trackpad to be connected. We are going to attach the battery screw. So we'll attach the battery screw to it. And then you see, I always try to put a guide because this can slip and then it's going to punch a hole on the battery, and that's it. We need to replace the battery. Because what you will get is you get the message that says service battery. And then also another thing is, you see how even though we didn't disconnect that, the ideal thing is not the ideal thing, you can choose to do it from the right or from the left, but usually I choose to do it from the left, not from the right. But one thing also is, you see, even though we did not disconnect that, always make sure to check it, because sometimes you may think that the client's battery is faulty, but it's just that the cable is not properly connected. So that is that. Okay, I'm just going to connect one speaker, and then I'm going to connect USB-C cable. We'll leave that. Yeah, let's just, okay, we will just, maybe we can as well connect the touch bar. So we just want to see if it works, and then we can continue to do with the rest of the assembly. Okay, so now let's connect our charger. Are we getting any fan spin? Not yet. It's supposed to give it a bit of a small delay. Okay, that's a beautiful sign, and that's a dunk. It's a beautiful one. So that's it tells us that that's the only problem of the machine, and the device is booting. So we are not going to wait for it to boot, obviously, because we don't want to show the name of the client, but that's the fix. This is just as this one turns out to be simple, but sometimes it's not that simple. Okay, so the next thing we want to do now is we want to put the device together. So the first thing I usually would do is I will start by putting back the screws, and then I'll start with the screws of the T5s, which is the ones on the main logic board, and then afterwards I do the T4, and then afterwards I do the T8, and then I put my cables together. So basically I followed just the reverse process of the first thing we did the first time. So usually I'm not the one to put it together, but the new guy we have is not there yet. We hope he's gonna, although he's catching up pretty fast, but yeah. So I know you guys are very much familiar with Peter, but now we have Shahid. 5%. Yeah, I think it should still be able to go. We yeah, that's more than enough. So we can use this here. It's more than enough to put it together. And then also when you're putting the board together, always make sure it's properly aligned. So sometimes it may align to one side but not align on the other side. So make sure it's aligned. For example, this side seems to be aligned but this side is not. So you want to loosen the screws and make sure that it is aligned. And that usually it's better to kind of follow a sequence, you know. So the ones for T's are done. Now let's quickly do okay, now the T4s, we may want to obviously connect the cables for the T4s, because most of we only have two T4s that need to go on the board, and then the rest will need the cables to be there. I hope the sound is still on, because it's this speaker, the mic that we're using. So yeah, right now we are quickly going to connect the cables, because most of the remaining T4s are going to require the cables to be connected. That is already connected. Let's have our Wi-Fi cable connected. This left speaker, mic, and then the left USB-C cable that is in place. Now let's quickly put back the shields. And while you're doing this, you make sure that you don't have power on the board. It's very important. You don't want to damage your board. The reason why I don't have that out is because I'm pretty confident that this is an Apple original battery, not a Chinese battery. So if it was a Chinese battery, I would also have to remove that. Okay, now this is not going to go. I need a screw to go there. Now there are two similar screws here. So one has a hole on top, and then the other one doesn't have a hole. The one that has a hole is the one that has to go on the right, because a screw has to go on top of it, and then the one on the left is the one that goes on the left side. Okay. Okay, we want to quickly put the white ones. Make sure it's aligned. Make sure you know where your screws are supposed to go. not to be too tight and not to be too loose. One of the screw seems to be missing. There we go. Okay, that's the last one. Now we want to connect the battery cable. Battery cover is actually missing. It wasn't there before, so we don't have to worry. It's also good to make sure you test so the first four. And put the mic now. Okay. Yeah, device is booted. Okay, it's actually no name. Okay, wait. Okay, yeah. So so it's fine. I mean, there's no name. So yeah. Okay, guys. Thank you, guys. I will see you guys in the next one.